So far, we've calculated how important students think each of the different factors are in terms of choosing a career, and we've also calculated to what extent they would expect each characteristic in their job. And remember, we scaled these on a not important as number 1 and as very important as number 5. So looking at the data, we can see there are a few differences, but not massive differences here. We need to know if those differences are significant. And to do that, we're going to use hypothesis testing. Using the guidance on choice of test, we select to do a t-test as a comparison. If you're not sure why, go back and read more about this. So we're going to do a t-test, which means we need to calculate the p-value. So just getting ready by putting in some borders, and we're going to calculate the p-value.
To do this, we need to look at the original data and not the means.
So we're calculating or planning a null hypothesis, which is that the data in the two columns is really pretty much the same. And the alternative hypothesis is that the data in the two columns are significantly different. For example, it might be that people think things are important but don't expect them to be evident in a career choice. So the two different hypotheses, the null hypothesis is that the two values are the same. The alternative hypothesis that the two values are different. We also need to set the value of significance. In other words, how willing are you prepared to be wrong? So if we choose a value of 0.05, that's equivalent to a percentage of 5. If you're unsure about percentages, ask your lecturer. So a 5% chance of being wrong is not a bad choice. If things were more serious, if we were maybe, for example, testing drugs, a 5% chance of being wrong would be much too big. But in general social statistics, 5% chance of being wrong is okay. So the significance level we're going to use is 0.05. And then what we need to do is to compare those two sets of values to find out what P is, and then we can decide whether to accept or reject the null hypothesis. So to do that, click where I want my answer. Now I know, because I've looked at the sheet, that the test I need to do on this particular data is the t-test. So I'm going to Formulas, More Functions, Statistical. I'm going to scroll down to find the t-test. There are 4 different sets of information I need to provide for the computer to do this calculation. So if I click on the little arrow for array 1 is the data for the first question. And the question, if we look here, is a job I find enjoyable. So what people think is important is this blue column. Click on the little arrow, and for array 2 I want the same question but in the pink selection, because this is what they expect. In terms of tails, this is asking if I already know which of those two sets of data should be larger, or if I'm not sure. Well, although I have a hunch, I really aren't very sure, and so I'm going to choose the 2-tail distribution. That simply means that the expectations could be higher or could be lower. Type in 2 there. If in doubt, this section here offers guidance. And what type of test am I doing? Well, again, we can use this guidance here. And this is a t-test that is paired. In other words, we have 2 different responses from each student. So it's paired, so this says we need to put number 1 in and then click on OK, and we have a p-value of 0.3. Now we need to come back to what we set as our significance level, and we said that the significance level was 5% chance of being wrong. So if p is less than 0.05, we reject the null value, but it's not. So we're going to accept those two sets of data, although they're slightly different, not significantly different, and therefore they are the same. Or at least we can't claim they're different. If we do the same for the next set of information, this is colleagues that I can get along with. So more functions, statistical, ttest, and the set of data this time is going to be people I can get along with for the importance, and then array 2 is for the expectation for the same question, people I can get along with. Same as before, I'm not really sure which is going to be higher, and in terms of the type, again it's still paired, same student answered both of those questions. Now if I click on OK, I can look here and I can see that this figure is also higher than 0.05, and therefore I have to accept the null value, that there isn't any significant difference. Again, remembering the tip before, if I want to copy down the cell above, Control and apostrophe. And I would go down and do the same for each of these different characteristics. So now I've calculated all of those p-values and I need to make sense of them. You can see there's a mixture here. We have, for example, a p-value of 1, and that's quite expected because what we're saying is these two are exactly the same. So we would expect it to be 100% chance. The figure above though looks a little bit strange because it's in scientific format. So I think what we need to do is to convert all of these into 4 decimal places. So if I go back to home, choose number with 2 decimal places, and then I can just increase it to 4 decimal places, and then I can actually see them a little bit more clearly. So this figure here we can see is actually smaller than 0.05. So we reject the null value. So the data is different. So there is a statistically significant difference for this particular question, what people want and what they expect. If we look at the next one, we've got exactly the same. There is a statistical difference. If we look at the next one though, it's much larger than our significance value, so we're going to accept the null value. Again, this one is bigger than 0.05, so we've got to accept the null, but this one is smaller, so we reject the null. And we can carry on going through all of these until we have completed them. So now that that's done, I'm looking for a way of making these stand out. So I'm going to use something called conditional formatting. I'm going to highlight these cells, and I'm going to, from the Home tab, use conditional formatting, and I want to use some highlighting rules, and I want to highlight it if it's different. So I'm looking for all those that are less than 0.05, and I want them highlighted, and I'm quite happy with that light red bill, but I could change it if I wanted. Okay, so all of those highlighted show statistical significance. So what are they? They are a secure job, pleasant environment, job which gives responsibility, high earnings, opportunity to travel, a good starting salary, and caring for others. So those areas are the areas where there is a significant difference between what people expect and what people want. Some of those people expect more than they want. So if we look at a job where I can care for others, people expect it more than they want it. If we look at the starting salary, people want it more than they accept it. If we look at job opportunity to travel, they expect it more than they want it. If we look at high earnings, they want it more than they expect it. If we look at responsibility, they expect it more than they want it. If we look at a secure job, they want it more than they expect it. And if we look at a pleasant working environment, they want it more than they expect it. I think for a moment, which of these two columns is going to lead to dissatisfaction with a job? Obviously, if you want something but aren't going to get it, that's going to be dissatisfactory. So this one and this one are going to be areas of dissatisfaction for employees as students see it, as does the high earnings and as does the starting salary. Now, if these are particularly important to students when looking for a job, then they expect to be less happy in their chosen career. And you can use this information to start to think about what it is that's important in a career, and for these students, the significance of that information. And this then can support the analysis of the information for your research discussion.